Welcome to the Data Hall YouTube channel. In this video, we are going to discuss how do we create portfolios or sort portfolios in R on basis of certain variable, and then what we do is we calculate those portfolio returns. So if you are working with certain analysis, for example, Farm and French factors or certain other factors, right? For that, what you need to do is you need to calculate the portfolios, make a portfolio of different stocks, and then what you need to do is calculate either value weighted stock returns, portfolio returns, or equal weighted portfolio returns. So this is what we are going to discuss in this video. There are different types of portfolios. We have univariate portfolio sorting. So what we do in univariate portfolio sorting, by the way, I have a whole video on Farm and French factors. If you search it on my website, I have explained in detail what univariate portfolio sorting is, how it is done, what bivariate portfolio sorting is, and all that stuff. So this univariate portfolio analysis is when we use a single variable, a single factor to sort stocks into portfolios. And in bivariate portfolios, we have, as the name suggests, we have two variables, two factors to sort stocks into portfolios. And then within bivariate portfolio, we have this bivariate independent sorting and bivariate dependent sorting. That is something that you'd have to check into that videos. But in this video, we are just going to focus on the univariate portfolio sorting. This is an in-depth topic of its own. In some other video, we are going to discuss the bivariate portfolio sorting. So let's load this data. Let's start working on the univariate portfolio sorting. So if we load this data, I have two different files that I'm going to load. First is the file that contains this yearly data. So we have different firms, right? These are numbered, right? So okay, and we have different years. So we have from 2015 till 2020. We have market capitalization, book to market ratio. And what happens is that when we create portfolios, we sort them on the basis of certain factors, right? And that sorting is done either yearly or monthly. Normally, usually it is done yearly. What we do is for each year, right, we would sort stocks on the basis of, let's just say, market capitalization. This is what is done in the Farm and French three-factor model. They sort it on the basis of the market capitalization. And once they sort it, they divide the firms into different portfolios, small stock portfolios and the big stock portfolios. But the idea is that sorting is done yearly, and then you can have either monthly returns, weekly returns, or daily returns of that portfolio, right? So portfolio creation is done yearly, but you can have other level of frequency, other frequency of data as well. Okay. So I'm just going to load this library. This is called the Tidyverse library. We are going to use this for the purpose of data manipulation and data management. Okay, so first thing is there are different ways of dividing stocks into different portfolios. We can divide them on the basis of median or standard deviation or mean, etc. Into two portfolios. Then we can divide stocks into equal size portfolios irrespective of the median. So we can have, let's just say, 10 portfolios of equal size. For that, we're going to use the xtile function. And then there is quite an interesting function that is called quantiles. We can use this quantiles function to divide stocks into different weights, right? So in different ways of portfolios, rather than having equal portfolios of right? So we can have different quantiles, different percentiles that we can use using this quantile function. And lastly, what I'm going to do is I'm going to discuss how do we calculate the portfolio return. And for that, I'm going to load this stock return file. So stay tuned to this video and let's learn this. Okay, so first thing first, we take this data set. Because I'm going to divide stocks on the basis of median. So we take the data, we group by year because the sorting is done on yearly basis. The portfolio creation is done on the yearly basis. Then we summarize the median. So for each year, we want to calculate the median of the market cap, right? Market capitalization. And that would give us an object called median. And if I can show you, it would have median for each year. So this is the median market capitalization. So any firm that is less than this median, that had a market capitalization of less than this median value, then that would be considered a small firm. And any firm that have a market capitalization of greater than this median value, then that would be considered a big firm, right? Okay, so what we do next is we create these portfolios, right? So we take the data file that we had, and we join this median values based on the years. So if I execute this and just show you the data, how the data looks like, you would see that we had median. So for each year, we would have the same median value. This median value is coming from this median data frame that we created. And next what we do is we create a column that is, let's call it size portfolios, using this case when function. What case when would do is it would create categories, right, on the basis of certain conditions. So if market capitalization is greater than median, then we need to have big stocks value in this column. If it is less than, then we need to have small stocks value in this column. In all other cases, if there is a missing value, let's just say, obviously it would be either greater than or less than equal to, but in case of a missing value, you would want to have an NA value and a missing value, right? So let me show you this. You can see that, so we had a median for 2015 because this value, this market capitalization is greater than the median value. It is considered a big stock. Similarly, this stock, because its market cap is less than the median value, so it is considered a small stock, right? So this is dividing these stocks into portfolios on the basis of median. We would later on look into how do we calculate returns of this big portfolio and the small portfolio, and maybe create the SMB factor. Okay. Next, we divide stocks into equal portfolios on the basis of using this xtile function. It is quite simple. We take the data, group by year as before. We create a new column. Let's call it Ntiles, number of percentiles or quantiles. And we use the Ntile function. We take the variable of interest and divide them into two parts. Now remember, when we divide them into two parts using this xtile function, it would divide them on the basis of median. But if we, let's just say, divided them into 4, then that would be divided not on the median, but rather than into quartiles, right? We can use any number of quantiles or percentiles. We can divide them, we can divide these stocks into portfolios. But in this case, I'm just going to do 2 portfolios. That is, it would divide them into portfolios basis of median, because when we use 2, that means median. And I'm just going to show you, okay, so let's move forward. And when I come at this line of code, I would show you that all these 3 methods had created the exact same portfolios, and there is no difference which method do you use if you are just interested in the median, right? Obviously, if you are interested in creating 10 equal size portfolios, then xtile is the best method. You cannot use median. But if you just wanted to divide them on the basis of median, standard deviation, or mean, etc., then this is the best method. And let's move to this last method, which is quantiles. So we take the data, group by year, and over here I'm just using the same argument that I used over here. I'm just creating this so that I can show you that both these methods, whether you use xtile or quantile, are exactly the same. So this is the exact same line of code. Do not worry about that. Now this is the new line of code. We have quantiles, and over here I'm dividing on the basis of market capitalization using the 50% probability. So divide them into equally, right? But I could have other, say for example, I could have done it like this, right? And what that would do is divide them into 3 portfolios. So anything less than 20th percentile and anything greater than 70th percentile would be different portfolios, and anything between 20th and 70th percentile would be considered a medium-sized portfolio. This is what I have done over here. That I will explain when I move over here, right? But for now, just stick with this 0.5 so we can compare these different methods. Now, once this quantile is created, I also want to create a new column that would be, so this quantile, what this quantile would do, let me close this bracket over here. Let me show you what this line of code would do, right? This is over here. It would just give us the quantile values, right? And not actually divide them into portfolios, right? So we have quantile values for 2015, 16, 17, right? These all values would be exactly the same because I have used 50th percentile. So that is giving me basically the median, right? So that is exactly the same value when we did the median. If you can see over here, this is the exact value that I got over here because I'm using 0.5. But if you had used, let's just say 0.7, then you would have got a different value. I just want to compare all these three methods. So that's why I'm using the exact same the median, division on the basis of median. So then what we do is we use this case when function as we did over here. And if market capitalization is less than equal to this quantile value, right? So if this market cap is less than this quantile value, then it would be considered 1. That is, we could have done it like this, small, right? That would be more clear to understand. And if market capitalization is greater than the quantile, let's call this big, right? Okay. And if anything is missing, then that would have a missing value in this column. If I execute this, let me show you this column. Now you can see that we had one in case of Ntile. When we use the Ntile function, one means it is a small portfolio, right? It is a small portfolio of small stocks. Now you can see over here that according to Ntile, whether we use Ntile or we use quantile function, we get the exact same firms into these portfolios. So exact same number of firms, exact same firms into small portfolio, whether I use the quantile function or the Ntile function, right? So this is the comparison of these three methods of creating these portfolios. And let me also, okay. Over here, what I do is I also join the portfolios that I created on the basis of median. So I can show you that those portfolios are exactly the same as, so this is the portfolios that we created on the basis of median. This is the portfolio basis created on the basis of quantile function. This is the portfolio created on the basis of the Ntile function. And if you can look at them, they are exactly the same, right? So I hope that clears certain confusions. Okay, so what we do next is we bring, we attach the relevant stock returns to these portfolios, and then we calculate the portfolio returns, right? So for that, let's import the stock return file. I have these monthly returns over here. These are the month end stock returns, right? We have this returns, we have year, and we have firm ID. Now what we are going to do is we are going to take these stock returns, merge the portfolios that we have created over here. So we know whether that specific stock, so we know this specific stock in this specific year belongs to a small firm portfolio or a big firm portfolio. So I take these portfolios, and because there are a lot of columns in this portfolio, what I am interested in is the firm ID, year, the Ntile, and the market capitalization, right? The market capitalization would be used to calculate weighted return. Now, remember, this is just a basic idea, right? There are a lot of things that would go in between these mergings, right? But I'm just going to give you a basic idea in this tutorial. We would have to adjust the time periods when portfolio is created, and when the portfolio sorting is done, and when we calculate the stock returns, right? There is certain gap into them in the literature. So let's join these portfolios that we created with the stock return data on the basis of firm and year. So let me just execute this line of code and show you how it would look like. So we previously just had returns from IDs. Now we know which portfolio it belongs to, and based on those portfolios and the date, right? Because we want to create stock returns, portfolio returns for each date, right? For each date, we create a weighted return that would be calculated on the basis of this weighted mean function. The return is the RET column and the weight is the market cap column. If I execute this, next what we need to do is we need to group by date and create the SMB column, which would be equal to the mean of the small stocks minus the mean of the weighted return of the big stock. So if I execute this whole chunk of code, we now have returns, right? But there are certain missing values. There are certain reasons for that, because this is just a dummy data that I've created for the purpose of this video. Okay. So this is how we calculated the SMB or the size factor. Again, there are certain other factors, there are certain other details to it. I do have a video on how to create Farmer and French 3-factor model in R. If you are interested in that, check the link given in the description, right? Okay, let's divide into different size portfolio. Over here, we are dividing into equal size portfolio. We divide it into 2 equal size portfolios on the basis of median, right? But let's just say in case of HML factor, right, we have to divide them into different size portfolios, because in HML we have this low, high and medium portfolios, and they are divided on the basis of if it is less than 30th percentile, then it would be a low book to market or a value stock. A growth stock. If it is greater than 0.75, it is a high book to market ratio stock, and then we have a median. So we are dividing into different size portfolios. So we take the data group by year, because portfolios are created for each year. We calculate the quantiles, the 30th quantile and the 70th quantile using the quantile function. I have explained them in this video. Then we create the BM portfolios, the book to market portfolios, using the case 1. Again, if the BM is less than the 30th quantile, it would be low book to market portfolio. If BM is greater than 70th quantile, it would be high book to market portfolio. If it is in between 30th and 70th, then that would be medium book to market portfolio. So if I can show you this, you can see that we have L, M and H representing whether it is a low, high or medium book to market portfolio. Next, we calculate the value weighted return. Now remember, if you didn't want it to calculate value weighted return, you wouldn't use this medium. Anyways, we would discuss that in some other video. Okay, we take stock returns. We join the portfolios as we did in this case, the portfolios that we created. And then we group by the portfolio and date, calculate the weighted return, right? Weight being the market capitalization, group by date, summarize, create the HML factor. Let me see what's the issue here. Okay. And we create the HML factor by taking the mean of high book to market ratio stocks portfolio minus the low book to market portfolio, and that way we would have the HML factor, right? Okay, so I missed the market cap over here, so I'm just going to add the market cap column that was missing, and if I execute this, we would have. Okay, let me show you these. So So we have this HML factor again. This is dummy data. So we had certain missing values, but anyways, you understand the process of calculating this HML and the SMB factor. But mainly again, there are certain other things that would go in between the creation of the portfolios and assigning the stock returns. So I hope this video was useful. Do subscribe to this channel, do hit the bell icon, and thanks for watching this video.